The denominator of this algebraic fraction has a repeated linear factor. In this video, let's learn how to obtain the partial fractions of such a fraction. You have learned that this type of proper algebraic fraction has partial fractions of this form. Look at this fraction. It is also proper, but its denominator has a repeated linear factor instead. How do we find its partial fractions? Can we still use something like this? Hey, the denominator x plus 1 all squared can be thought of as x plus 1 times x plus 1. Perhaps its partial fractions could look like this. Let's try to find the values of the constants c and d. As usual, combine the two partial fractions into a single fraction in order to compare with the left-hand side. Both sides are supposed to be equal, but their denominators are different. How do we make them the same? That looks right. Simplify the numerator on the right-hand side. Now we can equate the numerators. Let's try comparing the coefficients. From the terms in x, we have c plus d equals 3. Next, look at the constant terms. So c plus d equals 5. Wait a minute, something is wrong. C plus d cannot have two different values, so this method does not work. So what can we try? Maybe we can square both denominators. Then, combining the two fractions, we get c and d, a constant, in the numerator. But on the left-hand side, there is a term in x as well, so this doesn't work. How about if we just square one denominator? Let's see if this works. Combine them together. Looks promising. As before, we equate their numerators. Then compare the coefficients of x. So c equals 3. Next, compare the constant terms. So c plus d equals 5. Since c is 3, d equals 2. At last, we have an expression for this fraction in terms of its partial fractions. Is this definitely correct? Check it yourself. Combine the two partial fractions. Do you get the same fraction as the one on the left-hand side? Now we know that when a fraction has a repeated linear factor in the denominator, its partial fractions look like this. Let's see how to apply this to this fraction. The denominator has one linear factor and one repeated linear factor. What are its partial fractions? Let's consider each factor in turn. We already know that x plus 1 gives us this fraction. From what we have just learned, since 2x minus 1 is repeated, we will obtain these two fractions. Just as before, to find the values of a, b, and c, we first combine the fractions and then equate the numerators. Remember that we can either use substitution or comparison or both. Either way, you will find that a equals 1, b equals 2, and c equals -3. So the fraction is expressed in partial fractions like this. Here is another example. Its denominator is a product of a linear and a quadratic factor. What are the corresponding partial fractions? Recall that we need to factorize the quadratic factor into linear factors. Now can you see that x minus 2 is repeated in the denominator? So the partial fractions have this form. As before, we can equate the numerators and find a, b, and c. Then we can express the single fraction in terms of its partial fractions. Let's look at one final example. First, as always, check if it is a proper fraction before proceeding to find its partial fractions. Here, both the numerator and denominator are quadratic. So this is an improper fraction. Don't worry. Remember that you can use long division to express the fraction in terms of proper fractions. You will get this expression. Next, note that the denominator of the proper fraction can be factorized like this. Now we can find the partial fractions for this part. As seen previously, the partial fractions are of this form. Once again, we can equate the numerator and find a and b. Finally, our single fraction is expressed in partial fractions like this. Let's summarize. For a proper fraction with a repeated linear factor in its denominator, its partial fractions would be of this form.